the music of sound. Learning about characteristics of sound waves, speed of sound, range of hearing in humans, reflection of sound, and echo. Characteristics of sound waves. When sound waves travel through a medium, there is change in density and pressure of the medium. Compressions are regions where the particles are crowded together. At compressions, density as well as pressure is high. Rarefactions are regions of low pressures, where particles are spread apart. At rarefaction, density as well as pressure is low. The distance between two consecutive compressions or two consecutive rarefactions is called wavelength. Its SI unit is meter and it is represented by a Greek letter lambda. The change of density from maximum to minimum value and again to maximum value makes one oscillation. The number of oscillations per unit time is the frequency of wave. The frequency of sound wave is represented by nu. Its SI unit is Hertz, having the symbol Hz. About Hertz. Hertz was a German physicist who was first to broadcast and receive radio waves. He produced electromagnetic waves, sent them through space and measured their velocity and wavelength. He laid the foundation for future development of radio, telephone, telegraph and even television. The SI unit of frequency was named as Hertz in his honor. The time taken by two consecutive compressions or rarefactions to cross a fixed point is called time period of wave. That is, the time taken for one complete oscillation in the density of medium is called time period of sound wave. It is represented by T. For time period, SI unit is second. Relation between frequency and period is V is equal to 1 upon T. We can distinguish a male voice from a female voice. It is due to different frequencies produced by them and is characterized as pitch. Pitch is the frequency of vibrations of the sound source. For faster vibrations, frequency is higher and hence pitch is higher. The high-pitched sound corresponds to more number of compressions and rarefactions passing through a fixed point per unit time. When pitch is higher, the sound is shrill, while when pitch is lower, the sound is soft. Sounds of different pitch is produced by objects of different sizes vibrating at different frequencies. The loudness or softness of sound is determined basically by its amplitude. The magnitude of maximum displacement of particle in the medium on either side of the mean value is called amplitude of the wave. It is represented by A. Its unit is the same as that of density or pressure. Amplitude depends upon the force with which an object is made to vibrate. When sound waves move away from a source, its amplitude and loudness decreases. The characteristic of sound called as quality or timbre enables us to distinguish one sound from another having the same pitch or loudness. The sound which is more pleasant is said to be of a rich quality. A sound of single frequency is called tone. The sound which is produced due to a mixture of different frequencies is called a note. It is also pleasant to listen to. Music is of rich quality and hence it is pleasant to listen to. but noise is unpleasant to the ear. Speed of sound. The distance which a point on a wave, such as compression or rarefaction, travels per unit time is the speed of sound. So, the formula for the speed is distance upon time. Therefore, speed is equal to wavelength upon time period. V is equal to lambda upon time. Lambda stands for wavelength and T stands for time period. V is equal to mu into lambda. As we know the relation between frequency and time period, mu is equal to 1 upon T. That is, speed is equal to frequency into wavelength. Under the same physical conditions, for all the frequencies in a given medium, the speed of sound remains almost the same. The physical conditions of the given medium are related to the state of medium and temperature. The speed of sound decreases from solid to gaseous medium. If we increase temperature of any medium, the speed of sound also increases. The table below shows us the speed of sound in different media at 25 degrees Celsius. Range of hearing in humans. You may have observed bats flying at night or in the dark without colliding with walls or any obstacle. How is it possible for them? They can produce and hear sounds of frequency higher than 20,000 Hz, which human beings cannot hear. This sound is called ultrasound. Human ear also cannot hear sound of frequency less than 20 Hz. It is called infrasonic sound or infrasound. For example, sound produced by vibrations of pendulum. Sound produced before an earthquake by vibrations of the Earth's surface. The audible range of sound for human beings is from approximately 20 Hz to around 20,000 Hz. Children under the age of 5 and some animals like dogs can hear up to 25,000 Hz. But as people grow older, their ears become less sensitive to higher frequencies. Uses of ultrasound. Ultrasounds are used to establish ship-to-ship communication. They are used for welding plastic surfaces. Ultrasonic waves are used to kill bacteria in liquids like milk to preserve them for a longer period of time. The echocardiography technique is based on ultrasonic waves. Images of internal organs of the human body can be obtained in an ultrasound scanner. Ultrasounds are also useful in industries. They are used to clean parts located in places which are difficult to reach. Cracks and flaws in metal blocks can also be detected by ultrasounds. Reflection of sound. Similar to reflection of light waves, sound waves also get reflected at the surface of solids or liquids. They also follow the same laws of reflection. The only requirement for reflection of sound is an obstacle of large size having a rough polished surface. Take 2 cardboards and make 2 identical pipes of sufficient length. Arrange them on a table near a wall. Keep a clock near an open end of one of the pipes and try to hear the sound of the clock through the other pipe. Now adjust the angle between the 2 pipes in such a way that you can best hear the sound of the clock. Now measure the angle of incidence and reflection and work out the relationship between the angles. What will happen if the pipe on the right side is lifted vertically to some height? The direction in which sound is incident and reflected makes equal angles with the normal to the reflecting surface at the point of incidence, and these are in the same plane. Echo. Have you ever visited an echo point at any monuments? If you shout near that echo point, you will hear the same sound again a little later. This sound is called echo. It is a familiar example of reflection of sound waves from reflecting surface at a certain distance from the listener. Echo is repetition of sound due to reflection of original sound from any surface. The formula for hearing distinct echoes is distance is equal to velocity into time. And the SI unit of distinct echoes is m, that is meter. Summary. When sound waves travel through a medium, there is change in density and pressure of the medium. The distance between two consecutive compressions or two consecutive rarefactions is called wavelength. Its SI unit is meter and it is represented by lambda. So that is all in this topic. Keep going and keep learning.